Okay, hello everybody. Welcome to another screencast here. Today I thought I would go over some of the things that are going to be asked of you on the present assignment, and that is about the conduction of the heart. So on this diagram, or both of these diagrams, on the right, of course, is a cutaway view of the heart, showing the conduction system. We'll get into that in a little bit. And on the left-hand side, we see this is an electrocardiogram showing more than one complete what's called a cardiac cycle. Okay, and this is an electrical, or it's a graphical representation of the electrical activity of the heart. So anyway, let's go back to here. Every heart has the ability to beat on its own, regardless of any kind of nervous system connections. So to start it all off is a tiny little area right about here embedded in the wall of the right atrium. It's called the SA node, or sinoatrial node. So I guess I'll write that down, sinoatrial node. Okay, and that's where it all begins. So this, at about, the pace of the sinoatrial node is about 25 to 30 beats per minute. So sometimes this is referred to as the pacemaker because it sets the pace for the heart. Now, normally your heartbeat is about 70 beats per minute, and so to get it up to that level, you have two nerves. One is called the sympathetic, and the other one is called the vagus nerve, which the sympathetic speeds up the heart rate, and the vagus slows it down. Anyway, so it puts out an electrical signal that travels and spreads over the entire both right and left atria. Okay. And so this electrical activity of the heart is picked up on the electrocardiogram over here, and it comes out as this little blip right here, which is called the P wave. On here, you'll notice that, you can see it's measured in millivolts. So this is just showing the electrical activity of the heart. So the P wave represents the depolarization of the two atria. Okay. The actual contraction or systole of the atria occurs right about here, just afterwards. Okay, so that signal is picked up by this one. This one is called the atrioventricular node, or we'll just call it the AV node. And that picks up the signal and it strengthens it, and then it sends it out through the ventricles, through the bundle fibers, and then the Purkinje fibers, and then that tells the ventricles to contract. Okay, so that wave, or that depolarization, when the ventricles depolarize, shows up as this big blip. Now, you can probably kind of guess that the ventricles are big compared to, the muscle mass is big compared to the atria, so that's why we get this bigger blip. So this is when the ventricles depolarize. The ventricles actually contract, right in this area here. Okay, and then finally, the last blip that you see here is the T wave, and that is when the atria repolarize. Okay, I'm sorry, when the ventricles repolarize. The atria repolarize at the same time as the QRS complex. You just don't see it because it's masked here. Okay, so P wave, ventricle, or the atria depolarizing. The QRS complex is the depolarization of the ventricles. This is the repolarization of the ventricles. And then we get over here. This is one complete cardiac cycle right here to here. Okay. So hopefully this will help when you're filling out the worksheet. And guys, take care, and we'll see you soon, I hope. And thanks for watching.